Hello, viewers, and welcome again to today's class. Today, we're going to look at number system. And the learning outcomes for today's session is that you are able to explain what a number system is. Uh, Outcome two, you should be able to identify decimal, binary, octal, and hexadecimal. And three, you should be able to state the base of each system. And finally, you should be in a position to convert number between system. Onto the first bit of it. Basically, there are four numbering systems that are currently used either in programming or any computing world. The first one is a decimal numbering system, which is also known as base 10. Then we have binary, also known as base 2. Then we have octal, also known as base 8. And finally, we have hexadecimal, which is known as base 16. What you have to know is that each and one of these numbering system is used in a particular area in the computing world. Okay, let's begin with the first and foremost. Decimal or base 10 is the most common number ring system. And if you can look at the way it is, it takes us back to, I think it's grade 2 or 3, whereby we learned about ones, tens, and hundreds. So if you look at this particular number, this number it will be read like 352. 300, that is, it has 300s, and it has 50s, and it has 10 ones. So 352. So 50 stands in place of 10, 2 ones, and 3 in place of hundreds. And we're going to start by the most basic conversion, whereby if you're given a binary number, what you have to know is a binary number is also known as machine language. It's known as the computer's native language. Actually, this is the only language computer can understand, and it is in form of ones and zeros. So if you're given a number like this one here, 1011, and you're asked to convert it into decimal, what you need to do is that you know that each and every bit, let me call it bit, that is binary digit, is going to be multiplied by a power of 2, and you're beginning from right to left, whereby the rightmost bit will be multiplied by 2 raised to power 0. Then the next bit, it's 2 raised to power 1, and the power of 2 keeps on increasing as we move to the left. So after multiplying the bit by the power of 2, we add. So like what we have here, 1011, if we multiply it by a power of 2 and then add, we end up with 11 base 10. Quite simple, right? Okay. In any case, if you're given a decimal number and you're asked to convert it into a binary number, it's quite easy. What you do is you keep on dividing by 2 and retain the remainder. What do I mean by that? We're given number 25 here, and 25 divided by 2, the answer is 12, remainder 1. We retain the remainder as it is written here. Then we take the 12, divide it by 2, we get 6, remainder 0. We take the 6, we keep on subdividing until there's nothing more to be subdivided. So now 6 divided by 2 is 3, remainder 0. We retain the 0. Then we have 3 divided by 2, it's 1, remainder 1. Then we have 1 divided by 2, it's 0, remainder 1. So now there's nothing more to be divided. So actually what we do now is we start writing the bits from bottom going up. The bottom up economy now applies here. Okay, this is nothing to do with politics, but we start recording the bits from the lowest part to the up part. So actually, the decimal version of 25, actually the binary version of 25 is 11001. Sawa sawa. So if we are to work it the other way around, now we have the binary number and we need to convert it to a decimal number. What we actually do, we don't divide now. Now we multiply and then add, like just what we did previously. So a binary version, a decimal version of 11010 is actually 26, basing on the simple calculation that we said. We multiply by a power of 2 and then add it. You multiply the bit, so if the bit is 1 times 2 raised to power, it can be, it depends. If it's the rightmost bit is 0 and the leftmost bit depends on the number of bits that we have. So actually now what we have here is 11010 converted into decimal will be 26 base 10. On to the next numbering system, it's the octal. What you have to know is that octal is also known as base 8. And what it does, it divides the binary in groups of 3. So for example, if I'm given a binary digit of 101101, what I'll do is that I divide the bits into groups of 3 and I start with the rightmost going to the left side of it. So 101101, if I divide the bits, I'll get 101 is equivalent to 5 and 5. So 101101, the binary 101101 is equivalent to 5 base 8. And to the next numbering system, hexadecimal. What you have to know about hexadecimal is that it is also known as base 16, and it starts counting from 0 up to 9. When it reaches 9, now it switches to alphabet, that is A up to F. Actually, this is one of my best numbering system because now when it comes to selecting colors, a combination of letters and numbers can give you a color that you never knew that it existed. Okay, we'll look at that later on. So if you're given a number like 2F, base 16, and we need to convert it into decimal, what you need to do is that we have 2 and F. So you multiply 2 by 16. Then because F is less than 16 now, what you do is you just add. So 2F base 16 is equivalent to 47 base 10. So the biggest question is, why do we need all these numbering systems? You'll realize that for binary, it's normally used in computing world, in machine language, digital circuits, and all that. On the other hand, Octal compresses bits into threes, and Octal is mainly used in Linux and Unix environment, especially when it involves giving access rights of files to users. Then we have hexadecimal, whereby it comprises bits in 2 4s, and the one that we are always used to is the decimal numbering system. This one, it feels more natural to us humans. Then here is a cheat sheet. that will guide you when you want to convert one numbering system to another one. For example, if you need to convert binary to decimal, it's very easy. Look at the place values, then add. Decimal to binary, divide by 2, then reverse the remainders. Okay, you'll realize that you'll use this cheat sheet later on. Yeah, that's more like a tongue twister. Cheat sheet. I almost messed it up. Okay, we have real life applications of numbering systems. For binary, like I said, it's mainly used in computers, smartphones, digital circuits, and memory instructions and data storage. Decimal, it's mainly used in money measurements, counting prices. Actually, now this is what I meant by it's now real life. We always use it in almost everything that we do. Then we have the base 8, that is Octal. Like I said, it's used in Linux and Unix environment for file permissions, hexadecimal, web colors, IP version addresses, memory address, programming debugging is my best. Then we have BCD for digital clocks, calculators, electronic display and measurement devices. Okay, this is a summary. We have four numbering system. We have the decimal, binary, octal, and hexadecimal. And the next bit of it, it's a summary of all what we've done, and it will guide us through how to convert numbering system from
Discuss about
one.
the various number systems in maths. The four most common number system in maths are binary, octal, decimal and hexadecimal number system. We will learn about these number systems and the conversions between different number systems. Let's first understand the decimal number system. Have a look at prefix deci in word decimal. Deci means 1/10 of the whole. For example, decimeter. Decimeter stands for 1/10 of a meter. Decade stands for 10 years. The deci is associated with number 10. Hence, the decimal number system is a base 10 number system, which means that there are 10 different numbers in the decimal number system. Those numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Including 0, these are 10 numbers. Let's discuss about the binary number system. Have a look at the prefix by in word binary. Bi means 2 and hence the binary number system is a base 2 number system. It is represented by only two symbols or digits, that is 0 and 1. Computers use binary number system to store all data including number, word, video and graphics. Next is an octal number system. Look at the prefix octa. Octa means 8. For example, octagon. Octagon has got 8 sides. Hence, the octal number system is a base 8 number system, which means there are 8 different numbers in octal number system. Those 8 numbers are 0, 1, 2, 3, 4, 5, 6, 7. The next number system is hexadecimal number system. Have a look at prefix hexa. Hexa means 6. For example, hexagon. Hexagon has got 6 sides and we know that decimal corresponds to number 10. Hence, hexadecimal means 10 plus 6 is equal to 16. The hexadecimal number system is a base 16 number systems, which means it has 16 different numbers into it. Those numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all numbers from the decimal number system and additionally it has got 6 letters. Those are A, B, C, D, E, F. A corresponds to 10, B corresponds to 11, C to 12, D to 13, E to 14 and F to 15. These are all 16 numbers in the hexadecimal number system. Now let's learn how to convert the decimal numbers to binary number, octal number and hexadecimal numbers. We will do it using the method called as successive division method. Let's convert the decimal number 282, which is represented as 282 base 10, to the binary number. We know that binary number is base 2 number, and since we are converting the decimal into the binary number, we will perform the successive division by 2. We'll perform successive division by 2 until we get 0. So let's divide it by 2. 2 ones are 2, 2 fours are 8 and 2 ones are 2. There won't be any remainder. So you can see on right hand side, this is a column where I'm going to write all the remainders. Let's divide 141 by 2 again. So 2 sevens are 14, and how many 2's can go into 1? It's 0. It will leave 1 as a remainder. How many 2's can go into 70? 35, leaving remainder as 0. Now how many 2's can go into 35? It's 17. 17 into 2 is 34, leaving remainder as 1. How many 2's can go into 17? 2 8's are 16, remainder will be 1. Now how many 2's can go into 8? 2 4's are 8, remainder will be 0. How many 2's can go into 4? 2 2's are 4, remainder will be 0. Now how many 2's can go into 2? 2 1's are 2, remainder will be 0. Now how many 2's will go into 1? Nothing, and my remainder will be 1. Now we are good to write down our answer. So our answer is this remainders. We are going to write it down from bottom to top. This is very important, you should remember. So let's write it down. 1 0 0 0 1 1 0 1 and 0. This is the binary representation of number 282, which is a decimal number. Friends, if you like our work, then please hit on the like button and pass your valuable feedback. Let us convert 282 base 10 to the octal number now. Octal number system is a base 8 number system, and since we are converting decimal to octal, we will perform the successive division by number 8. So let's divide 282 by 8. So 8 threes are 24. If we subtract 24 from 28, we will get 4 as a remainder. Let's take this 2 down, so it will be 42. 8 fives are 40, so we'll get 2 as a remainder. 42 minus 40 is equal to 2. Now let's divide 35 by 8. So 8 fours are 32, remainder will be 3. How many 8 can go into 4 now? It's nothing. Hence 4 will be the remainder. Now we will write this number from bottom to up to represent it in the octal form. So let's write it down. 432 to the base 8, which means 282 base 10 equals to 432 base 8. Let us convert the same number 282 to the base 10 to the hexadecimal number now. Since hexadecimal number is a base 16 number system, what we are going to do, we'll perform the successive division by number 16. So here we go. How many 16s can go into 28? So 16 ones are 16. The remainder will be 12. So we'll take this 2 down. So it will be 122. 16 sevens are 112. So 122 minus 112, it will give remainder as 10. Now how many 16 can go into 17? It's 1. We're leaving remainder as 1. How many 16 can go into 1? Nothing. It will give me remainder as 1. We know that in hexadecimal number, number 10 is represented by letter A. 1 and 1 will be as it is. Now let's write down this number from bottom to up to represent it in hexadecimal format. So it will be 1, 1 and A, which means 282 to the base 10 equals 11A in base 16. Because about the various number systems in maths, the four most common
Basing on that video, I hope you've gotten some of the knowledge you need. And to test if you've gotten something from the short video, I have a simple task for you here. I have 5 tasks and I need you to do it, and you can share your answers in the comments. For now, it's a thank you and bye. See you again. Kwaheri.